Well, hello, my name is Jeff Lime, and I'm here to talk about Wi-Fi going beyond basic coverage. It's a lot more than coverage these days. It's about capacity, and now it's about aesthetics. So we're going to cover these three topics in a little bit of detail. I'm from Ventev. Ventev Wireless Infrastructure is a unit of Tesco Technologies where we manufacture antennas, enclosures, cabling, mounts, everything you need to deploy a Wi-Fi system without the access point. We don't make the access point, we make the entire ecosystem of accessories that helps deploy that access point in the right intended environment. Today we're going to talk about less about Ventev, more about what's happening with Wi-Fi. We're going to talk about the Wi-Fi evolution. We're going to talk about the challenge of ensuring capacity, which is the big challenge these days. It used to be about coverage, now it's about capacity. And then we're going to talk about it's beyond capacity now. Now it needs to look good. And finally, we're going to show some unique solutions that Ventev has brought to the marketplace. So the Wi-Fi evolution. It's similar to the cellular evolution. If you think about what happened in the cellular business back in the days, even before LTE, it was about, do I have a signal? Then it was, as I'm roaming, can I still keep my signal? Now, it's about, I expect my cell to work everywhere. Indoors, outdoors, everywhere. Ubiquitous, without roaming, without transfers. Specifically in the United States. Wi-Fi is following a very similar trend. Wi-Fi was about, is there Wi-Fi here? Then it was about, I expect Wi-Fi to be here. Now, it's about, I expect my Wi-Fi to work fast and be free. Streaming data, streaming video, venues like this, we expect to be able to get to the internet, get to our data sources via Wi-Fi just about everywhere we go. So we're following a very similar trend. But let's throw some stats out there. The graph up here in the upper left shows the number of mobile device shipments. And in 2013, over 1 billion mobile devices were shipped. In 2014, over 1 billion smartphones were shipped. And that trend is continuing. In fact, there are more mobile devices on Earth than there are people these days in use. And some interesting statistics. Last year alone, in 2014, mobile traffic grew 69%. And if you compare that to the entire internet in 2000, mobile data traffic is now 30 times the size of the entire internet back in 2000, just 15 years later. And that trend is continuing. Over the next 3 years, another 7 billion mobile devices, Wi-Fi enabled, will be shipped. And we don't stop there. Data traffic is now greater than voice traffic. So what's interesting about all that? It's not just about, do I have coverage? Now it's about, do I have the ability to see what I want to see and send what I want to send? If you look at this picture, I think this picture is great. This really shows off what happened. This is Benedict becoming Pope in 2005. This is Francis becoming Pope in 2013. Both of these are from St. Peter's Square. There was one mobile device in this picture in 2005, and it wasn't even a smartphone. Look at this. Look at all of these points of light. These points of light are all mobile-enabled devices, all tech capturing the moment, all wanting to upload their pictures to whatever site or friend or wherever they're sending it, or tweet it, or Facebook it. This is what's happening. If you take a look at Mobile World Congress is held in Barcelona every year. Cisco Systems has to put together the network. It's a 7 square mile area. They put in 1,000 access points in that 7 square mile area. At one point during the show last year, they recorded 100,000 simultaneous connections in a 7 square mile area. That's capacity. Now think about CTIA. Think about how many people are on the show floor right now, and how many people are trying to access the internet at the same time. We're talking not just, this is just a common place, this is St. Peter's Square. Auditoriums, stadiums, all kinds of places people expect to have Wi-Fi. So like I said, it's not just about coverage anymore. It's not just about, is there Wi-Fi here? Now it's, does the Wi-Fi perform the way I expect it to? So traditional coverage-oriented Wi-Fi is basically inadequate anymore. I love this picture. This is a classroom, a university classroom, and we're going to get into a case study here pretty soon. This university classroom is a great example of all of the Wi-Fi enabled devices that are trying to simultaneously access the network and share the information that the professor is trying to deliver. Stadiums is another great example. Hospitals are another great example. Wi-Fi is everywhere, and people are expecting it. So how do we solve this challenge? How do we solve this challenge if it's not just coverage anymore, it's capacity? Well, one solution is to put in more access points. We could just put in more access points and over-cover the area. The challenge with putting in more access points is that you get cross-channel interference. So the way we like to solve that is by segmenting the area into smaller RF cells. And you can do that with what we call high-density antennas. So you take a high-density antenna, similar to this one, and it's a sectorized antenna, a panel antenna, that will direct the signal in certain sizes. Traditional antennas are omnidirectional antennas. Omnidirectional antennas are like incandescent light bulbs. They light up the whole room. Directional antennas are more like floodlights or spotlights, depending on the beam width that you are delivering. So using high-density antennas, you can segment an area and spotlight different sections of that room, and I'll go through that in a case study. It limits the number of users per access point, and thereby gives you more bandwidth per user. It's ideal for sports venues, convention centers like this, auditoriums, classrooms, things of that nature. So one solution is to put in more access points, but then use high-density antennas to segment off and control the cross-channel interference. In fact, here's a chart from Ventev where we show all of these are different skew numbers, and it's showing the different beam width, how wide or narrow the beam is, and the different gains. So this is a great selection chart to say how much gain do I need and how broad of a spectrum do I want to cover. And it shows the wide variety of products that we have to offer. And I promised you the case study. So Georgia Tech is a partner of ours. They've allowed us to use their name in this case study. And I've already shown it off in that one picture of the classroom. 5 or 6 years ago, when Georgia Tech first put in their network in their lecture halls, there's 300 students per lecture hall. 5 or 6 years ago, maybe 50 students had one single Wi-Fi enabled device in that room. Now, laptops are an issued item at the university. So now those 300 students are now coming into that lecture hall with a laptop, a smartphone, and many of them have a tablet and maybe one other device. So now we've gone from 50 devices in that room asking for Wi-Fi to anywhere from 600 to 1,200 devices in that room asking for Wi-Fi. The network couldn't handle the capacity or the bandwidth requirements. So we went to Georgia Tech, we helped Bill Lawrence solve the problem by installing APs with Ventev high-density antennas that basically took that room and segmented it into 10 different sections of 30 students each, thereby managing the bandwidth. Before we put in the high-density antennas, all those devices were, when you did a site survey, all those devices were aggregating in 2 or 3 access points. Now we're managing the bandwidth and managing capacity across all 10 access points by segmenting the room. It was a great solution and a great win, and Bill Lawrence has a pretty clever quote here. Good old Southern boy. Less bandwidth means poor quality. It's like sharing a pecan pie. If you have to share it with 12 people, it won't be as good as if you had to share it with only 4. So now we're going beyond capacity as a challenge. Now it needs to look good. So when you're trying to put in high-performing Wi-Fi networks, you also need to make sure it blends with the environment, almost that it's invisible to the environment. So the next challenge that we're trying to solve, and the next challenge that many of our customers are facing, is how do I make this, because we're putting in more infrastructure, blend with the environment? Hospitals are a great example. Schools again, office buildings, resorts, entertainment venues. You want to have high-performing Wi-Fi, but you don't want to see it. So the solution, we have 3 different solutions we're going to talk through right here. We're going to talk about concealing the infrastructure. We're going to talk about smaller form factor infrastructure that has the same performance. And we're going to talk about camouflaging the infrastructure. One example you can see over at the kiosk where we've got the Ventev solutions is a ceiling tile enclosure. What the ceiling tile enclosure does, think of a tegular ceiling or a drop ceiling. Instead of hanging that access point off of the drop ceiling, and you probably all remember the days where the access points had the omnidirectional antennas, it looked like a spider hanging off the ceiling. Well, now with the nice, newly well-designed access points from all the access point manufacturers, they're more aesthetically pleasing just in their industrial design, and the antennas are integrated internally, and they're higher performing antennas. But you still have to hang them from a drop ceiling. What we like to sell and promote is a ceiling tile enclosure. It does several things for you. 1, it protects that access point. 2, it secures the access point. 3, it gives a better looking environment, and it blends it all into the environment without anything protruding from the ceiling. This is a great solution in hospitals for infectious disease control. How many times have you walked through a hospital and you see an access point hanging from the ceiling 2 inches below the ceiling? Because it's attached to the ceiling tile grid on its T-bar clip. Well, that space between the access point and the ceiling is a great place for dust to collect. How many people do you think go through and dust the top of those access points? Not very many. And when they're not dusting the tops of those access points, it allows dust to get into those environments and creates an infectious disease issue. So ceiling tile enclosures are not only great for aesthetics, they're also great for the performance of the hospital. We design these in a lot of different forms with bubble enclosures to actually secure the access point and protect it from the environment, with drop doors, with integrated ceiling tile enclosures for most of the most of the access point manufacturers. Another challenge, conceal. This is a solution where we've integrated our high density antennas with an access point and the cabling infrastructure into a co-location mount. These are great for convention centers like this, where you might want to hang it from the ceiling. They're great for large auditoriums, concert halls. And what happens is when you see these from the face or from that high up, what you see is basically a speaker cover. It doesn't look like Wi-Fi infrastructure anymore. It actually looks like a nice speaker cover. So we make these for all the different access point manufacturers as well. The nice part about this is you can assemble it down here on the ground and then go up in the high lift and mount it. And you don't have to hang up there and do all of the infrastructure installation in an unsafe environment. So co-location mounts are a great way to do this. Another solution is small form factor antennas. So now we've left conceal, and now we're moving into design. This is an omnidirectional antenna. This antenna was designed to deliver dual band, 2.4 and 5 gigahertz. This is for a 4-lead access point versus a 3-lead, but we make them for all the different ones. And it's small enough form factor that it would actually fit inside of a light canister. So now imagine you're in a retail environment and you don't want to see the Wi-Fi infrastructure, but you want to do point of sale, you want to do all kinds of other things with your customers. Think about your ceiling now. You've got all these spotlights in the ceiling for or spotlights and canisters spotlighting different products in your retail store. You could put this in one of those canisters and you've got Wi-Fi in your store. So this is a great solution, both indoor and outdoor, of starting to hide the antennas so that so you have a more aesthetically pleasing environment. Another small form factor antenna that you'll see at our kiosk is this new 6 dBi omnidirectional antenna. This is affectionately called a paint can antenna. This is the most popular outdoor omni antenna on the marketplace. We've now made the same antenna 2/3 the size with the same performance. So now as you're getting into more outdoor environments where you've got higher density deployments, you want that infrastructure getting smaller and smaller. And I'm going to show you how to conceal it even more and camouflage it in a couple of slides. So here's another great innovation where we've taken the same physics of RF propagation and put it into a much smaller package. In fact, here's that picture. And because these radomes are plastic, as well as our enclosures are plastic, many of our customers are able to camouflage them and use paint that is appropriate for ABS or polycarbonate and start to camouflage these infrastructures into the environment. So camouflage is the next step in aesthetically pleasing. So we've got conceal it, smaller form factor, and now camouflage. And here's another great example of camouflaging an enclosure in a garden bed where it's more difficult to see the Wi-Fi infrastructure. So that's moving from coverage to capacity to aesthetics. And now I'm going to show you some more challenging environments that we've solved, which I think are pretty interesting. In many environments, you've got a lot of RF challenges as well as infrastructure challenges. I'm going to walk you through an example here in a minute about the cruise lines, but you think about cruise lines, resorts, gymnasiums, warehouses, places where there's a lot of RF interference or a lot of ground to cover. The challenge is, how do you still provide that Wi-Fi and deliver the aesthetics? So similar to this convention center, think about a warehouse environment. Think about all of the RF scanners that are in these warehouses these days. Think about asset tracking. Think about maintenance crews walking around with tablets trying to maintain all the equipment in the warehouse or in the manufacturing floor. Most of these floors have what we call I-beams. If you look up here, you're going to see something looking like an I-beam. One of the challenges is installing that equipment. What we've created is a whole line of I-beam warehouse mounts that allow you to install that infrastructure on the ground in an aesthetically pleasing way, and then go up and mount it to the I-beam already all put together. So here's a great example of your access point, an Omni antenna, your bracket system, all your cabling system, all of it's already pre-installed on the ground, and then you install it when you put it up in the ceiling. And when you look up in the ceiling, it's all more organized than seeing an access point, a whole bunch of cabling, and then an antenna. Here's another example of having an enclosure also as part of that system. So that's a great solution. We also have a unique solution that's a spring-mounted antenna, I-beam antenna mount. So think about fork trucks that are driving through with a lot of material on the forks. They're not paying attention. They hit those antennas. If that antenna is hard mounted, you just broke the antenna. You lost your Wi-Fi. But because of this new I-beam spring mount that we have, it gives and it keeps on going. The other challenge with Wi-Fi in these warehouse environments is that many times people do the site surveys before all of the warehouse material is put in. The rack systems might be there, but it's not stuffed. Once you stuff those rack systems with all of the inventory, it changes the RF experience. So it's very important to go back in and look at the RF patterns in site survey after everything's loaded. And you might find that you're going to need more directional antennas. You might find that you're going to need different types of solutions. Gymnasiums is another great example. How many times have you seen in a gymnasium an access point mounted to the wall with that blinky light? And how many times do you think that students are trying to throw basketballs at that light? And then how many times do you see that the maintenance crew has a brilliant idea and says, let's protect the access point. And they put a metal cage over it, just like they put over the clock. Well, that metal cage is what? An RF interference source, right? A better solution is to use a Ventev polypropylene bubble enclosure. Allows full RF propagation, protects the access point, and also conceals it. Cruise ships. One of the most exciting things that we've done recently is cruise ships. Just about every cruise line carries our enclosure and antenna system. We provide Wi-Fi for the patrons, for guest Wi-Fi. We provide Wi-Fi for the POS systems and for the operations crews. But what's interesting and what's most interesting about this is the challenge that we solved. It's an RF interference source. A ship is all steel, and it's a highly caustic environment, salty sea air. So one of the things we like to do is translate that to more market-based opportunities. What else looks like a cruise ship? Well, you can immediately go to merchant vessels, other types of freight liners, but really when you start thinking about it, it's RF interference in caustic environment. Offshore oil rigs, chemical plants on the seashore. You can start imagining all the different places where these enclosure and antenna solutions can provide a better Wi-Fi deployment for your customers. And we do it in both powered enclosures and non-powered enclosures. That's what I have for you today. Again, I want to wrap up by saying a couple things. Wi-Fi is going beyond coverage. It's not just about, do I have Wi-Fi? How well does that Wi-Fi perform? And now that we're putting in more infrastructure, am I able to not see that infrastructure in these aesthetically pleasing environments that I'm putting it into? And at Ventev, we're trying to solve all these challenges every day. We look forward to talking to you over at our kiosk if you have more questions. But I thank you for the time.